Good morning. This is Tuesday, April 14, and this is the 11th day and the beginning of the third week of our online presentation. And we're going to be covering the second skill that will be a second of 5 skills that will make up collectively a test, as I have described to you before. And I still will be sending you an email. I didn't get a chance to do that yesterday, but I will do it today, outlining again how these skills will be rolled up into tests and be used to improve your score. And I want you to remember that no one's grade will go down. So I'm going to write this. And if you want to take a picture of this, do so. No one's grade will go down. Whatever it was at the third quarter, that's the lowest your grade would be. Now, to improve your grade, then your skill score must exceed your third quarter percentage grade. Okay? So let me write that down. To improve your grade, your skill score which is, of course, the score you get for each of these skills, must exceed your third quarter percentage grade. Okay? Must exceed your third quarter percent grade. All right. So we're going to now go through the basics on the skill that we're covering. So today we're going to be solving quadratic equation by factoring. And so I have the steps listed here. So first you're going to solve for the variable, of course. That's the ultimate goal, solve for the variable, according to the following steps. So step 1, we give you an example. We want you to factor x squared minus 7x equals 0. So here's an example now of the factored equation. It isn't just the example, it's what it would actually be. If you factored x squared minus 7x equals 0, you would get x times x minus 7 equals 0. That's the factored form. Then your second step is you're going to use the following helpful rule, the zero product property rule. And that rule basically says, using an example, if x times x minus 7 equals 0, then x must be 0 or x minus 7 must be 0. So if x equals 0 or x minus 7 equals 0, then we can take those two separate equations and solve for x. So x equals 0, it's, that's the answer. So I just rewrite it here. But then I take x minus 7 equals 0, I add 7 to both sides, and I get x equals 7. So the solutions then are x equals 0 and x equals 7. So that's basically what we're covering for today's work. Now we're going to go through several examples. Okay? And of course, before we do that, be sure you use a sheet of paper that's inserted in a plastic sleeve so that you can do this work. If you don't, you're liable to make errors and you will not get to that score level that you want. And again, remember that if you use a dry erase marker with this, then erase, you've got the ability to do your problems over and over again on one sheet of paper. All right, so let's go on to the first of two skills that we're going, first of two examples that we're going to do. So the first example, we're going to solve for x in the equation 7x squared plus 11x plus 4 equals 0. Okay, so I'm going to, let me get my little red pencil here, a red pen. I'm going to, first of all, I'm going to remind you that the coefficient in front of x squared, and that's 7, and then the 11 here, those are a and b respectively, and the constant is your c. So you've got an a, a b, and a c there. And your job here is, first you've got to factor this equation. So we're going to factor and we're going to start out by taking a times c here. So we're going to take a times c, and a times c in this case is going to equal 7 times 11. So we'll write 7 times 11. I'm sorry, not 7 times 11, it's a times c, so 7 times 4. Let's change that to 7 times 4, okay? And 7 times 4 equals 28. So again, a times c is 7 times 4, which equals 28. All right, now we are going to need, factors of 28. That add up to 11. Which is, of course, the b up here. Here's your 11, it's your b. So looking at this, we know that 7 times 4 equals 28. That's just off the top of my head. But 7 plus 4 equals 11, which is what our b is. So we'll write that down. 7 times 4 equals 28. That's a times c. And 7 plus 4, or a plus c if you will, equals 11, which is your b. Okay? So you're going to replace b, which is your 11x. Notice the x comes with it because all of b is 11x actually, even though, well, it really isn't. b is 11, but you're replacing the term 11x. So we'll try to keep that differentiated. So we're going to replace b with 7x and 4x. Okay? So literally what we're doing here is we're splitting up 11x into 7x and 4x. So let's write it out the way it would look. We'll start out here with 7x squared plus, and then we're going to take the 7x over here. And then we're going to add the 4x to it. Plus 4. And that all equals 0. And if you remember, 7x plus 4x, that actually equaled the 28. I'm sorry, not the 28. It equaled the 11x, which was the middle term. So 11x here is broken into 7x and 4x. Okay? All right. And so now let's go ahead and throw parentheses around the first two terms and the last two terms so that you can see that you have two binomials that you're going to factor. So we have 7x squared plus 7x and I'm going to put parentheses around that binomial, plus 4x plus 4. And I'll again close that parentheses, and that equals 0. All right. So now that we've done that, we can go ahead and actually do our factoring. So if you look at the first binomial, 7x squared plus 7x, I can factor out a 7 and I can factor out an x out of each of those. So I'm going to take 7x and factor that out, which is literally dividing it out. But of course, reverse is multiplication. That's why it looks like that when we get this done, it looks like that you're multiplying 7x to, in this case, it would be x plus 1. Okay. And then over here, 4x plus 4, I can factor out a 4. So I will do that. And that leaves me again with x plus 1. 4 times x plus 1. And that all equals 0. So now that I've done that, I can rewrite this equation by taking the 7x and the 4, adding those together. And I'm going to multiply that polynomial, or I'm sorry, binomial that I made times x plus 1, which of course is repeated here. And because it's repeated in each of those are multiplied times 7 and 4, we can do 7x plus 4 times x plus 1. And equals 0. So now that we've done that, we're going to use the zero property rule to find what x is when y equals 0. So use zero property rule to find x when y equals 0. And it's always assumed, even though you don't see a y in any of this, that this 0 that you see all along here is really your y. Okay? All right, so using the zero property rule, we're going to take 7x plus 4, and we're going to make that equal to 0. And we're going to take x plus 1, and we're going to make that equal to 0. So now I'm going to undo. I'm going to subtract 4 from both sides from 7x plus 4. And the 4 and the negative 4 cancel, and I get 7x equals negative 4. Then I divide by 7 on both sides. And that 7 divided by 7 becomes 1. 1 times x is x. So x equals negative 4 over 7. So that's our first solution. And then x plus 1 equals 0. This one's easy. We just subtract 1 from both sides, and we get x equals negative 1. So that's our other solution. And now that we have those, we would write our answer as follows. Notice our negative 4 over 7. I'm going to write it, it goes into a box in IXL. And so you can only write it this way, negative 4/7 for negative 4 over 7. And then negative 1 for the other one with a comma in between. Now, if you look at what the instructions ask with these kinds of problems, they will tell you to do this, to set up your fraction as negative 4 side slash or slanted slash 7 for negative 4 over 7, and then a comma, and then the next answer. Okay, so that's basically the way you would do it. And so now that you've got that taken care of, we'll go to the last example. So the last example I deliberately chose both these two examples because of the a times c. Over here, with the previous example, all the terms were positive. Now I'm going to show you what happens when you've got negative terms like this. Okay? All right, so we're going to use the exact same process that we did before. We're going to factor, and then we're going to use the zero property rule. Okay? So, again, my a, in this case, is going to be 2. My b is going to be negative 27. My c is going to be negative 14. I'm going to factor. And that process starts with me finding a times c. So a times c is going to equal, in this case, 2 times negative 14. 2 times negative 14, I'll put that in parentheses because the multiplication sign and the negative sign shouldn't be shown together. Considered indecent, right? Okay, and so 2 times negative 14 equals negative 28. So, I need factors of negative 28 that add up to add up to negative 27. And if you remember, that was your b. Here's your b here. So negative 27. It's your b. All right. So you're going to take negative 1. We're going to start out with negative 1 times negative 1 times positive 28. Start out simple. And negative 1 times positive 28 equals negative 28. And then I'm going to add those two together. So negative 1 plus 28, well, that happens to equal negative 27, which was that's what b is. So since we know what those are, we know that those are going to be our terms. So we're going to replace b, which is the negative 27, times the d. Now let's just do it this way. So we're going to replace b with we're going to replace the b, and that's negative 27, but there's a d attached to it. I'm just going to say that. With 1d and negative 28d. Okay? So here's the negative 1. And let's see, this is positive 1. I'm sorry. And this is negative 28. Let me see if I did this right. Positive 1, negative 28. And this should be positive 1, negative 28. I wrote these down wrong. Okay. All right. 1 times negative 28 is negative 28. 1 minus 28 is negative 27. So I got my positives and negatives confused when I wrote this down a little earlier. But this is correct now, and so I know that my 1 will replace 1d, will be replaced with 1d, and the negative 28 will be replaced with negative 28d. All right, So let's go over here and start our factorization. So I'm going to take the 2d again, which is the first term, 2d squared, and I'm going to add 1d. Okay. And then I'm going to subtract 28d. And then I'm going to add the negative 14, or subtract 14, and that's going to equal 0. Okay, so you can see again, I took negative 27d, and I broke it apart into positive 1d and negative 28d. Okay? All right, so now I'm going to go ahead and rewrite this into two binomials. So I have 2d squared plus 1d, and that's in parentheses, plus, and I have negative 28d minus 14. And all of that added together equals 0. Now I'm going to go ahead and do the actual factoring. So I'm going to factor out, in this case, a d from 2d squared plus 1d. So I'm going to factor out a d. And it leaves me with 2d plus 1. And over here, I'm going to factor out, looks like, negative 14. So that would leave me with positive 2d, and then the negative 14 divided by negative 14 is positive 1. And that all equals 0. So now I can rewrite this. You'll notice I've got 2d plus 1 in two places. One's multiplied to the d and one is multiplied to the negative 14. So because of that, we can take d and negative 14 now, and we can create d minus 14 times 2d plus 1. And that equals 0. All right? Now we're going to use the zero property rule. And again, it's really it's to find what x is when y equals 0, but I wrote it in my previous on my previous page, and so I'm just going to leave it simply like this. All right, so let's see here. Let's straighten this out a little bit. We're going to take d minus 14. Let's take away the parentheses. We don't need that anymore. So d minus 14 equals 0. And I'm going to use 2d plus 1 equals 0. So d minus 14, that's easy. We add 14 to both sides, and we get 14 and negative 14 canceling, and so d equals 14. So that's one of our solutions. And then 2d plus 1, I undo, so I subtract 1 from both sides, and I get 2d equals negative 1. Then I go ahead and I divide by 2. The 2 divided by 2 cancels, and I end up with d equals negative 1/2. So my answer here is 14. X is 14 when y is 0, and x is negative 1/2, or negative 1/2 when y is 0. And there's my answer. And we're done. Okay? So that's it. I'll let you go. Have a great day. Thank you now.